Hi, good morning, everyone. I'm Justin King. I'm a product manager at Dell, and I concentrate on AI solutions and outcomes. So I've been asked to come today and talk about some work that Dell's been getting interested in and working around some of the challenges around autonomous driving and what that means. And so I'm going to go through this demo environment, walk you through it. There is a link that you can all have access to it yourself, and you'll be able to, in your own leisure, be able to navigate and look at some of the topics that I talk about. But in general, what is the greatest tech challenge of our time? Autonomous driving is going to be is the future. It's here today, but it's still not perfect. Even Elon can't resolve this, and so we're still working. But it's the data that's needed to create this environment, this connected world. And so, as you can see on the screen here, I could be driving down the street with my car. I'm collecting data all the time. I'm collecting whether there's pedestrians walking, where I am in the lane on the road. I'm looking at objects around me. I'm being able to navigate. So I'm collecting this data, but the car is going to be consuming around 25 petabytes of data a day if I was just to collect that data and do nothing with it. I cannot put that storage and leave that in the car. So I've got to have this connected world where I'm able to offload and transfer that data. I can't do it over the air. Over the air is limited if I'm using like an LTE signal. I'll never get 25 petabytes a day through LTE. So I've got to be able to have this connected world where buildings and devices around the environment like charging stations, traffic control signals, things like that, they're going to be enabled and connected so that as I'm driving, I'm able to bridge that over-air connection, communication, to be able to offload that to other areas. And so, but this only helps the manufacturer bring new features, higher quality control for safety into the environment as part of that. But what about the consumer? The consumer can, the driver themselves, they can benefit from this connected world as well with the car itself. And so what that means is I'm streaming videos. The kids are watching videos on their iPads and stuff in the back. I could do that over LTE, but I can bring this connected city and have faster bandwidth as part of that. So I get a better experience for that. I could be talking to shops, restaurants as I'm driving by. They have the opportunity to market themselves. So if there's any deals or trying to get you in the door for a reservation, they can begin to use this connected world to help empower the driver and the contents of the car so that we're able to further get a value proposition out of this in this connected world. But delivering this connected world is very challenging as part of that. So let me look at what are some of the challenges that we have. Well, there's a development cycle. We can't do this in real time if we're taking a car and then manually plugging it in, transferring the data, and then analyzing that data, and then doing updates, and then sending those updates back. The life cycle aspect of that is just too long. But we have to be more reactive. We have to work faster. And so getting beyond the time to do this DevOps environment, we've got a data scientist shortage. They're demanding where they want to work, for who, and what salary at this point. We've got the, what's the other one here? Software-defined architectures. We can't be looking at point solutions. It can't be just like, here's a data collection point for the ECU as an example. We've got to be looking at the entire ecosystem and putting architectures that are validated. That's what my team does. I have a couple of engineering teams. They validate these solutions from end to end so that you don't have to go through the grunt work and go through and learn this yourself. We can help you get faster to market as part of those. And so as we move into the infrastructure aspect here, I'm just going to kind of, for the sake of time, as I said, this is available to you, but we're going to start over on the left. We've got our mule. This is our test car. This has additional sensors, additional cameras. We have some of our PowerEdge edge servers, the XR line of servers, sitting in this mule. This is going around a test track. This could be going out on the actual streets in controlled environments. It's collecting this data. But then we have these remote mobile road sites. This could be a container full of storage and servers, but the data that's been collected, I've got to get off the car. I've got to keep the car characteristics similar to what the driving experience is going to be. So if I put servers and storage inside the car, I'm going to be putting additional weight, additional characteristics are going to change how the autonomous elements are going to handle that. So if I maintain a family of four, two adults, two kids, and maintain that, I'm going to get more success with how my end-to-end autonomous driving algorithms are trained and updated and work in production as part of that. So we're offloading the data. This data is then going through a process where we bring it into the data center. We're going to go into a bit more detail in a second. I'm just showing the infrastructure that's used as part of this. But we have this core data center. This is where all the data comes in. It's where our data engineers are working, where our data scientists are working, and able to take the end-to-end process of getting data, cleaning the data, starting work with that algorithm, training that algorithm, getting quality assurance with that, and then getting compliance, and then effectively putting it into production so you can deliver autonomous driving to the manufacturers can deliver this to their own customers running their cars as part of that. We've got our near edge with the retail stores and regional data centers. You know, bringing the compute nearer to where the source of the data is going to help speed up the process and management of that data as part of that. And then what about smart factories? Not only can we use it for day-to-day operations in terms of your trucks arriving and doing the mundane things, but what if we can have self-processes running in the car that can do diagnostic and send that to the manufacturer directly so the manufacturer can get awareness and be able to continue the evolution of updating those fixes, those bug fixes, getting the models tweaked even further, and getting those updates back into the car as part of that. So again, I'm able to, in real time, be able to continue not just building an autonomous driving solution, I'm able to respond in real time as part of that, potentially. And then as we get into the multi-cloud aspect of this, we've got our data management that really encompasses the whole end-to-end aspect. We've got the cloud. People are not working in a single office now. We're working everywhere, whether at home, in the office, on the go. So we've got to be able to stay connected as part of that. And then all of this runs as, you know, you can click on each one of these boxes once you get the link, and you'll be able to go and see what products are listed, but obviously Dell servers, Dell networking, Dell storage provide the functionality of this. But we also have Apex as a service aspect, so we can have compute and storage, and that can be the underlying fundamentals of the infrastructure as a whole. But if we go more into what is the autonomous aspect of this, you know, we've got a very similar map here, but we've got our car coming in with data collection. I'm just going to run through this real quick. But we've got the data coming in as part of that. We've got a couple of software titles. This is coming in. This is going around a test track, as I mentioned, and getting information processed. We bring that in. We've got to then transfer that to storage so that we can begin the whole data processing of smart ingest, and data curation, and scenario extraction. If I know I can do an unprotected left turn, I'm going to extract that feature so I can be able to optimize the model and train it much more efficiently as part of that. Data curation, as I mentioned, and extraction. Then we get into the actual data center itself, the core data center. This mimics kind of a single element. It could be multiples. It could be stretched across multiple sites as part of that. But this is where we really get to see our data engineers and data scientists what the challenges they have as they work and build this environment to provide autonomous driving as part of that. So we've got the data streaming. We've got it coming in from the car into the mobile data centers. It's copied in, and we're analyzing as it comes in as part of this. We've got to do data mapping and labeling. We've got to extract features, put labels so I can find them very quickly. I've got to have quality assurance. Everybody knows if your data is not of a high quality, you're not going to get the results that are needed to have, especially with an autonomous driving car, you've got to be as accurate as possible. And yes, there is no 100%. Data compression, using something like PowerScale and ECS, we're able to compress the data. So as we have these petabytes of data, we're able to bring it down into small, manageable chunks. We've got a metadata management. This is really where I catalog the data for fast retrieval. Create catalogs, I'm able to search for that data in a much faster way. So this is really what the data engineer aspect of the autonomous driving program is. Then we move more into the data science aspect here. We take all of these catalogs, we then begin to create our algorithms. And so we're using things like machine learning operations. I'm going to skip through here. Each one has its own subset here. But we get into the MLOps aspect, using GPUs, Kubeflow as part of that. And we take those catalogs, those data, and then with that algorithm, we've got to begin to train it. So we replay the data to look to see if I get the same results every time. Or if I get different results, then I've got to understand why I'm getting different results and be able to respond accordingly. So replaying is very essential as part of the data. I then got to do open and closed loop testing. This is very critical to make sure that the quality and the assurance of that data is there. We then got to put it into simulation. This is something that I have a separate project running on right now. But to simulate autonomous driving, how many miles can you drive in a day? You know, if you're driving around San Francisco, you'll be lucky if you do 500 miles just driving for 8 hours, you know, and that's aiming at a 65 miles an hour nonstop drive. If you need to do 100,000 miles, that's impossible for a human to do, or you're going to need fleets and fleets of cars. And so taking an ECU, putting it into an infrastructure and a twin city environment, I'm able to simulate that and add features into that mix so that I'm able to get a much more data into my training model and therefore a more accurate algorithm as the outcome there. I then have some safety that needs it, and then we've got to go into homologation, which means the federal government allows me to certify this, approve it, put this into the market. So as a manufacturer, my cars can be then sold to customers, or these features can be added to cars as part of that. And then just wrapping up here, we've got data management sitting in Apex as part of this. We've got our public cloud. As I said, we want to stay connected. It's not public first. Public cloud is a way to help bridge things, but hybrid cloud is more and more common is what we see at Dell. And so being able to have private clouds, being able to span into the public cloud is part of that, or even just offsite locations. But again, all of this running with Apex as the underlying platform for this AI, autonomous driving, allows us to really give you a sense of the challenges of handling the massive amounts of data that comes in when it looks at autonomous driving. And so based on that with the time, I'm going to wrap it up there. But if you go to dell.to/automotive, you will be able to get this link and be able to go through this whole demo yourself in your own pace, clicking on all the blue links to the spec sheets and data sheets that support this. And thank you for your time.